Alright, at this point, let us now create an IP plan or network plan for our requirements, which is to define 5 subnets. Okay? In creating our IP plan, we need 3 columns, namely the network address, the range of the valid host, and we also have the broadcast address. Okay, so to start with, we need to define our network address. So our first network address here will be based on this list. Okay, previously we have created 8 possible combinations or 8 possible subnets. Okay, but we can only use 6 valid hosts here according to the formula. Okay, so we can only produce 6 valid subnets. So let us try to plot these subnets. Okay, based from the original network address, so we have 172.16.0.0. Remember, 172.16 remains unchanged. So we just simply rewrite it. We have 172.16. Okay? Concentrate on the 3rd and the 4th octet. We have borrowed 3 bits from the 3rd octet. So the resulting number are as follows: 0, 32, 64, and so on and so forth. Okay? So we put this one on the 3rd octet. So the first is we have 0. Okay? That, again, the 4th octet remains unchanged because we only touch the 3rd octet here. Okay, the 1st, 2nd, and the 4th octet remains unchanged. So that will be 0. Okay, the second network address, we simply copy this one. We have 172.16.32.0. And the same for the remaining numbers. So we have 172.16.64.0, 172.16.96.0, 172.16.128.0, 172.16.160.0, 172.16.192.0, and lastly we have 172.16.224.0. So these are the 8 subnets that we created, but only 6 of these are usable. Okay. So what are the 2 subnets then which are not usable? Okay. So let us define it. Okay. So the first network address and the last network address, these are the 2 network addresses which are not usable. Okay, why? Because if you notice, the first network address is the same as our original network address from the given. Okay, and later on we can find that the last network address is not also usable because this will be our broadcast address. So we can only use the 6 subnets in between. But since we only needed 5, okay, just choose 5 among these network addresses. Okay, so this will be our first column. Next, we need to define also the range of valid hosts. Okay, we need to define the range of valid hosts. So how? Let us again rewrite the numbers from the 3rd octet. Okay, so we have 0, 0, 0. Remember, the first 3 bits from the 3rd octet is now belong to our network bits. So we'll not change this one. We have 0, 0, 0. And then we simply copy that one, 0, 0, 0, 0, 0. Okay. That the fourth octet, concentrate on the host portion. Okay. We are defining the number of hosts here. Okay. The number of valid hosts. So therefore, we just simply concentrate on the host bits. Okay. So the fourth octets are also a host bits. So we start with 0 also. Alright. So if the host portion, or if the host bits are all zeros, basically these are our network address. So if we are going to convert this one into its decimal equivalent, this is also equivalent to 0.0. Okay, notice these are our network address. So therefore, the first valid host here, we need to set this one into 1. This is the starting number. Okay. And after converting it into decimal, 0.0000001 is actually equivalent to 1 in decimal. So therefore, rewriting this one, the first valid host will be 172.16.0.1. Okay, this will be our first valid host. How about the last valid host for this network number? Okay, so if we are going to set or continue, okay, continue assigning ones from the host bits. So the next number will be 1, 0. Okay, so 0, 0, 0, 0, 1, 0. So this is equivalent to 2. Okay, and then followed by 1, 1, that is equivalent to 3, until such time that all of these host bits will be filled with all ones except for the network bits. Okay, so there will come a time that all host bits will be filled with all ones. Okay, at this point, when say if all host bits are turned into all ones, that will now be our broadcast address. Okay, this will be our broadcast address. I repeat, if all host bits are turned to all ones, this is our broadcast address. This is in contrast with the network address. If the host bits are turned into all zeros, this is our network address. Okay, so our broadcast address now will be 172.16. That we have 31.255, because if we convert this one, 1111 is actually equivalent to 255, and then this one is equivalent to 31. Why? So we have 1, 2, 4, 8, 16. So 16 plus 8, 24 plus 4, 28 plus 2, 30 plus 1, that's 31. So the broadcast address therefore is 172.16.31.255. Alright? How about our valid or last valid host? Okay? So we cannot turn all host bits into all ones because this is our broadcast address. So the last bits, or the last bit rather, should be turned into 0. So that if we convert this into decimal, this will be equivalent to 254. Okay, 254. And this will be now be our last valid host for this network address. So we have 172.16. We have 31.254. Okay. Let's proceed with the next network address, 172.16.32.1. Okay, the 32.1. So that 32 is actually equivalent to 001. Okay, 001. So let's erase this one. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Alright. So this is equivalent to 32.0, which is our network address. Our first valid host address at this point will be, okay, turning the rightmost portion or the least significant digit of the port octet into 1. Okay, so if we convert this into decimal, this is 32.1. Okay, 32.1. So the first valid host from this network address will be 172.16.32.1 until, again, if we turn this into all ones, if we turn all host bits, our host bits into all ones, we have 1, 2, 3, 4, 5 at 1, 2, 3, 4, 5, 6, 7, 8. This will now be equivalent to 32 plus 16 plus 8 plus 4 plus 2 plus 1, that is equivalent to 63. And 11111 is equivalent to 255. Okay? So this will be our broadcast address. 172.63.255. Right? And to define the last valid host for this particular network address, we turn the last bit into 0 and convert it into decimal. So this is 254. Right? So our last valid host for this network address will be 172.16.63.254. Okay, so we see now the pattern. Okay, concentrate here. See the pattern or observe the pattern. The first valid host is actually will start with 1. Okay, as well as on the second network address. Okay, 0 then 1. Next, look at the third octet, which is 31. Okay, 31. So we simply deduct 1 from the next number, which is 32. So 32 minus 1 is 31. And the last valid host is 254. Okay, so we cannot turn all host bits into all ones because this is our broadcast address. Okay, so if we follow this one, okay, the same is true with the second network number. We have 32.1. This will be our first valid host. Next, last valid host is 172.16.63. Okay, this is based from the next network address, which is 64. We simply deduct 1. So 64 minus 1 is 63. and the last number is 254. Okay, so we rewrite 172.16.64.1 until 172.16. The next number is 96. So we simply deduct 1, that 254, and then broadcast address 172.16.95.255. Alright, next we also have 172.16.96.1 until 172.16. Minus 1 again, 127.254, and then broadcast address is the address next to the last valid host. 172.16.127.255. Okay, continue the process. We have 172.16.128.1 until 172.16. Okay, next number is 160, so we deduct 159.254. Okay, the next number after this will be our broadcast address, 172.16.159.255. Okay, next we have 172.16.160.1 until 172.16. Deduct 191.254. Okay, next is the broadcast address, 172.16.191.255. Okay, and lastly we have 172.16.192.1 until 172.16.223.254. Broadcast address 172.16.223.255. Okay? So we only need 5 subnets as per our requirements. Okay? We only need 5 subnets, and we produce 6 usable subnets. Okay, it's up to you. It's up to you. What subnets are you going to choose among the 6 valid subnets? So you may choose the first 5 subnets. Okay, so the first, second, third, fourth, and the 5th subnet. Question here: what are we going to do with the remaining usable subnet? Okay, so this subnet will be used as our reserve subnet. This will be used for future expansion. Okay, so let us not use this one. Okay, because we already defined our 5 subnet requirements. Alright, so our IP plan for this subnetting requirements will be this one. At this juncture, let us now define the usable subnet mask for each of these subnets. Okay, so when we say subnet mask, we actually set all network numbers to all ones and all host bits to all zeros. Okay, so remember, for Class B network, the ID is n.h.h. the first two octets belong for the network bits or the network ID, and the third and fourth octets are for our host ID or host bits. Okay. So expanding this one, similar to this one, if we try now to set all network bits into all ones, so we have 1, 2, 3, 4, 5, 6, 7, 8 that, 1, 2, 3, 4, 5, 6, 7, 8 that, and turning all host bits to all zeros, 1, 2, 3, 4, 5, 6, 7, 8 that, 1, 2, 3, 4, 5, 6, 7, 8. This will be our default subnet mask value. Okay, default subnet mask value. So converting into its decimal equivalent, this is 255.255.0.0. Okay, this is the default subnet mask. Alright? But since we created 5 subnetworks for this network address, we need to redefine also its subnet mask value. Okay? So we will not going to use anymore the default subnet mask. Okay? Since as you notice here, the third octet, the first 3 bits from the third octet is now belong to the network bits. Alright? So therefore, if we turn all network bits into all ones, this will be 1, 2, 3, 4, 5, 6, 7, 8. That 1, 2, 3, 4, 5, 6, 7, 8. That the first 3 bits from the third octet belongs to the network. So we are now going to turn these bits into all ones as well. And the remaining 5 bits belongs to the host. So we turn it into all zeros, as well as the fourth octet. And convert this into its decimal equivalent. So this is 255 that, 255 that. Okay, so this is now equivalent to 128 plus 64, that is 192, plus 32, that is 224. 224.0. This will now be our custom subnet mask. Okay, so this subnet mask value will be used across all of these subnets. Alright, so we cannot use the default subnet mask because we just perform subnetting. So it is right for us to use our customized subnet mask value. So to answer further why the last octet or the last subnet rather is not usable, because it is our subnet mask. Okay, so we cannot use the last subnet.